Welcome to our class on understanding calculus. I hope you liked last time's lecture. We'll continue our journey into the study of functions. Today we will study some special properties of functions. First thing that we'll study is what is an even function and what is an odd function. An even function is defined as f of minus x is equal to fx. For example, if you know the value of fx and suppose if fx is equal to say something like y. Now if you instead of x you substitute it with minus x, then to the answer is y, then this is known as even function. That means fx and f of minus x will give you the same output. For example, in this, suppose if there is this x-axis and there is a y-axis and there is a graph. Now for this value of x, you have this value of y. For minus x, again you have the same value of y. Now over here, for this value of x, you have this value of y. And for minus of this x, again you have the same value of y. So when this happens, it is known as an even function. This even function is symmetric about the y-axis. That means whatever graph you have on the right side of the y-axis is reflected on the left side of the y-axis. You will get exactly the same type of graph. So whatever values of y you get for x, the same value of y you will get when you put minus x. That is an even function. Then odd function. Odd function is defined as when you substitute x with minus x, you get minus of fx. That means suppose if fx was say z, then instead of x, if you write minus f of minus x, you will get minus z. So this is reflected around the origin. For example, if this is your x-axis and y-axis and this is your graph. Now suppose if this is your x, you get y over here. If you put minus x, you get something over here that is minus y. Here also if you put x, this is y. If you put minus x, you will get minus y. So that is the difference. Here when you substituted x with minus x, you got exactly the same y. Here you get minus y. So that is the difference. So this is odd function. It is symmetric about the origin. So when you go this way x and then y, you go x and then down y. Whereas here when you do x and y, even if you go towards minus x, you will again go up and y. This is the even function, this is the odd function. This is symmetric around the y-axis, this is symmetric about the origin. The function need not necessarily be odd or even. It could be either odd or even, or it could be neither of them. So suppose if you have your x-axis and your y-axis and you have a straight line graph. Now for example, if this is your x, then you will get this y. Instead, if you get minus x, you will get this y. Now this y is not the negative of this, nor is it equal to this. So you get somewhat totally a different y, which is neither the negative of this nor equal to this. So you may get something which is neither y nor minus y. And hence the value of this is not equal to this nor the negative of this. So it could be neither of them. So it need not necessarily be an odd function or an even function. Then we talk of what is known as a periodic function. Now periodic function repeats after a fixed interval. Something like a sine function. You have seen this type of a sine function which are graphs and the whole thing repeats after some time. So this is known as a periodic and this is known as a period. So if you take 0 to 2 pi, the whole thing will keep on repeating before as well as after. So this is known as a periodic function. We will study periodic functions in more detail later on. Then we talk about monotonic functions. Now monotonic functions are functions which are strictly increasing or decreasing. That means a graph will just go up or it will keep on going down. Either way it is possible, but it can't go up and down again. Then it is not monotonic. If it goes only up throughout its course, or if it goes only down, then it is known as monotonic. If it goes up and down, it is non-monotonic. Then we talked about the classification of functions. This should be really mastered. Important things that you should know about each function are the domain, the range, the graph. You should know the graph of each function very well, whether it is odd, even, or neither of them, periodic or not periodic, and monotonic or not monotonic. So we discussed the different types of functions. First is the algebraic function. First we'll enumerate them and then we'll go into the details of each of them. First is a polynomial function. This consists of a constant function, a linear function, a parabolic or an even power, and cubic or odd power. Then we talk of rational functions. These are usually reciprocals, and the reciprocal could be of an odd power or an even power. Then irrational function. This is the under root function, so it could be even root or an odd root. These are also known as radical functions. And we have piecewise functions. This is a signum function, the modulus function, the greatest integer function, the least integer function, and the fractional part. Then we talk of transcendental functions. These are the trigonometric functions, the inverse trigonometric functions, the exponential functions, and the logarithmic functions. Now, in a polynomial, one thing that you must remember is what is known as the degree of the polynomial function. The degree of the polynomial function is the highest power of x with a non-zero coefficient. Now, suppose if you write a polynomial as say a x raised to the power n plus b x raised to the power n minus 1 plus c x raised to n minus 2 and so on till say m x n plus n. Now here this n is an integral value. It has to be an integer, something like say 5, 6, 7. So these are integral values. They can't be fractions or negative numbers. So this is a and a, b, c are constants. They are the arbitrary constants and they are the coefficients. Now you can have some of them as 0 also. So then that particular term may be missing. For example, c could be 0 or b could be 0. But the first term cannot be 0. For example, if a is 0, then this term will just vanish. And then you can start with b into x raised to n minus 1. So the first term cannot be 0. If it is there, if it is 0, then you start from this and not this. Any of these terms could be 0. So you can have decreasing powers of x. Some may be missing, that's fine. And ending with a constant. N is just a constant. Now consider this 3x plus 5. Here the highest degree is 1. Here the highest degree was n. So this has a degree n. Here the degree of the polynomial is 1. Here the highest degree is cube. So the degree of the polynomial is 3. Now if you have a constant, then this can also be written as 2 into x raised to the power 0. So here the degree of the polynomial is 0. But if the constant itself is 0, then the degree is not defined. So if there is a constant and the constant is not 0, then the degree is considered as 0. But if the constant itself is 0, then the degree is not defined. The degree of the polynomial could be either odd or even. Now if it is odd, this will be the shape of the polynomial, and if it is even, this would be the shape of the polynomial. So what you must remember is, in any polynomial, the maximum number of terms is equal to the degree minus 1. It could be less, but it cannot be more than that. Now what this means is, suppose if there is a equation of the function of this type, a x to the power 3 b x to the square plus cx plus d. Here the degree is 3. Now 3 minus 1 is 2. So this graph can have a maximum of 2 turns. Now this is a turn. This is a turn. That means the graph is increasing. It turns, then starts decreasing, or turns and then starts increasing. Now this can be 2, or it can be even less than 2. It may be 1 or it may be 0, but it cannot be 3 or more than 3. The maximum is 2. Now if this is your function with the degree 4, then it can have a maximum of 3 turns. Now what I want you to remember is that if the degree of the polynomial is odd, then on this side it will tend to minus infinity, on this side it will tend to plus infinity. So the domain is the entire set of real values and the range is also the set of real values. That means it can have any input value and it can also have any output value. Whereas if it is an even degree, then the graph will go this way and it cannot have more than 3 turns, and there will be a, suppose if the graph is opening upwards, then there will be a minimum level. That means either it could be this or it could be somewhere else also, but there will always be a minimum level. That means it may be here, it may be here, but there has to be a minimum. The maximum could be infinity, but there will be a fixed minimum level. Now here the domain is the entire range of real numbers, but the range will the upper value of the range will be infinity, but the lower value there will be a fixed value. Now if the degree of the a or the leading coefficient, that means the coefficient in front of the highest power is negative, then the graph would be downward facing, means something like this. Then it would go something like this. So here you will have a highest maximum value and the lowest will be minus infinity. So on one side it will face the infinity, but on the other side it will have a limiting value. If a is positive, it will have a lower limiting value. If a is negative, it will be downward opening and it will have a highest limiting value. Now this could be odd or even sometimes, and it may or may not be, depending on what are the values of a, b, c, d, e. If it is a standard graph of this type, then it could be either odd or even, but otherwise if the a, b, c, d, e are random values, then it may not be odd or neither odd nor even. Periodicity. Now usually these graphs are not periodic. The only periodic graph you will see in polynomial is if it is a constant function, that means y is equal to c, where it is said to be periodic with period undefined. We'll see that a little later on. And monotonicity. Now even powers obviously will not be monotonic. Odd powers may be monotonic because it may be strictly increasing, and if it is linear it will be monotonic, otherwise it will not be monotonic. Now we consider this special graphs. Now here we thought of x to the power 3 and x to the power 4. Now this red graph is x to the power 3, the blue graph is x to the power 4. Now you can see that the domain and the range for this red graph is R, whereas the domain for this is R, but the range will be from 0 to infinity, including 0. So this is x cube and x raised to the power 4. Now we consider the constant function. Now if this is your x-axis and this is your y-axis, this constant function is y is equal to c, where c is an arbitrary constant. Now whatever input value of x is there, the output value will always be c. So irrespective of x, the output value is always c. Now the domain is the set of real values. The range is only a one singleton value, which is c, and a singleton value, as I told you earlier, is written in curly brackets. So the range is only c and nothing more, nothing less. And this is a periodic function because it the same thing repeats itself, and here the exact period is not defined. That means you do not know how much is value you have to take to repeat. So this is a periodic function where the period is not defined. Then we talk of the linear functions. Now the linear function, this is your x and y axis. Now this is your linear function. So here the domain is it's a straight line defined as y is equal to mx plus c. Domain and range are the set of all real values. Monotonicity, it is monotonic except if x is 0. If x is 0, it will this will become y is equal to c, which will be a constant function. Otherwise it will be either going up if m is positive, and it will go down if m is negative. If there is a straight line like y is equal to x, this is also described as an identity function, because whatever value of x is there, the y will also be the same. So that is described as identity, means whatever input, the same output you will get. So that is an identity function. Then we study a few more graphs. One is a parabolic graph. Now this is y is equal to x square. Now here what happens is, it goes down, and in an even function there will be a limiting value and it will go up. Suppose if you consider y is equal to minus x square, then it will be exactly the opposite way. It will be reflected in the x axis. So this is the black graph, is the graph of y is equal to minus x square. So this is y is equal to minus x square, this is y is equal to x square. We'll see transformations a little later on. Now in this parabola, the domain is the entire set of real values. It can take any value of x. But the range for this standard parabola, the upper limit would be infinity, but the lower limit will be 0. In case the parabola is not of the standard type and it is of the type y is equal to x square plus bx plus c, then the limiting value would be minus d upon 4a, where d is equal to b square minus 4ac. From this equation you find out what is d. This is your b, this is a, and this is c. So d is the discriminant. So d is equal to b square minus 4ac upon 4a. So that will give you the limiting value, and the other value would be infinity. If it is a, it will be plus infinity, and this will be the minimum value. If a is negative, then this will be the maximum value, and lower value will tend towards minus infinity. Then we see some other graphs of even powers. Now here you have your even powers, and here you have this x square. Then this is blue is the graph of x raised to the power 4, and green is the power of graph of x raised to the power 6. Now these graphs will pass through 1 1 and minus 1 1. See, now if x is equal to 1, then x 1 raised to any power would be 1. So it will pass through 1 and output will be 1. If x is equal to minus 1, then minus 1 raised to an even power will be plus 1. So it will pass through minus 1 and 1. So it will pass through minus 1 1 also. Now a few more things that you have to observe in this graph here are that if x is more than 1, the graph of x square will be lower than graph of x raised to the power 4, which will be lower than graph of x raised to the power 6. For example, if x is 2, then x square will be 4, and if x is raised to the power 2, it will be 4, and if x is 2 is raised to the power 4, it will be 16. So 16 will be above 4, and hence the power 4 will be above, and power 6 will be even higher. But if x is less than 1, then things are a little different. Then x square will be above x raised to power 4, which will be above x raised to the power 6. Because suppose if it is x is half, then half square will be 1 upon 4, and half raised to the power 4 will be 1 by 16, and 1 by 16 will be lower than 1 upon 4. And similarly on the negative side. Then we come to the qubit or the odd powers. Now here we have the red graph x raised to the power 3, blue is the x raised to power 5, and green is the x raised to the power 7. Now these will pass through 1 1, that is fine, because if x is 1, 1 raised to any power will be 1. But if x is minus 1, then minus 1 raised to an odd power will be minus 1. So it will pass through this point, minus 1 and minus 1. Unlike an even function which will pass through this point, odd function will pass through this point, minus 1, minus 1. Here it will be the same on this side, but here it will be different. If it is an even power, it will pass through here. If it is an odd power, it will pass through this point. And here also, if x is more than 1, x raised to 7 is higher than x raised to 5, which will be higher than x raised to 3, whereas it would be the opposite way if x is less than 1, and similarly on the negative side. So you have to see two things. One is the degree of the function, which is whether it is odd or even, which will tell you whether the its graph will be going down and then up, or it will just go up. That means whether it will be on positive and negative side of the x-axis, or it will be only on one side. And the leading coefficient, whether it is positive or negative. The leading coefficient, if it is positive, it will draw the graph this way for an even function, and if leading coefficient is negative, this way it will be for an even function. For an odd function, if the leading coefficient is positive, it will go this way. If the leading coefficient is negative, it will go this way for the odd function. So thank you for watching today's lecture, and please subscribe and like the channel and share it with your friends. Thank you.